The age of the mammals had truly arrived, and it was ugly. This is Entelodont, not the kind of thing you'd want to meet, even in a nightmare, unless you happen to be a paleontologist like Dr. Scott Foss.
I've often thought about what it would be like to meet an entelodont. I always imagine these as being creatures that were just really would have an attitude. They'd walk into a room and say, "I'm here."
No one would argue with such a mouthful of weapons.
The mouth of the entelodont is pretty incredible. And we know from these huge muscles up here that would pull on the jaw that these animals had a very strong, powerful bite. And they were able to grab onto things and twist and rip it away. I'd say the words would be pulverized, breaking, mashing, crushing, grinding, grabbing things and dragging them and twisting them and pulling them. They were scavengers, they were generalists. They could do anything they really wanted to do.
But even the biggest, nastiest creatures have their enemies.
From looking at entelodont skulls, we find bite marks, sometimes in the side of the face, right up here. We find it right up here in the forehead. And sometimes we even find bite marks in the roof of the mouth. And if you can imagine that, bite marks into these creatures, what creature could do that? What creature could get its jaws around an entelodont? Another entelodont. We know that because their teeth actually could have made those bite marks. Also, there's not a single other animal alive at the time that could have made bite marks like that. So we're pretty sure it was entelodonts doing this to each other. The big question is why? Well, today animals will do battle with other animals of their species, mostly for mate competition or territory competition. It's probably a form of competition, a very painful form of competition.
Entelodonts were the ultimate all-purpose animals, built like tanks and able to eat anything. A typical mammalian success story.
It's really hard to say why we don't have entelodonts today, why they didn't make it. I suspect if we were to release entelodonts into North America today, they might do very well. These things are generalists. They'd eat anything in front of them. I imagine they'd especially like potato chips and hot dogs and things like that. They'd probably do very well until they got into a populated area, and that would be the end of this. I don't think there'd be room for both people and an entelodont in some suburban neighborhoods.
The Entelodonts were a new breed of large mammal. But it wasn't long before they were upstaged by the largest land mammals ever to live. On Roy Chapman Andrews' expedition in Mongolia, the Dig Diary records the discovery of a single bone big as a man's body. Some of those enormous bones found their way to the Natural History Museum in London. Bones over a meter long should be easy to find, but there are a lot of bones in the Natural History Museum for paleontologist Professor Mikhail Fortilius to search through.
This is the bone of a very large animal. If I found this somewhere, I would probably think that it was an elephant. because it's very, very large. But in some ways it's like a giraffe, and in some ways even like a rhinoceros. But it isn't like anything alive today, and it's much, much bigger than anything that lives today.
It took scientists a while to work out what sort of creature it was. The only thing that was clear was that it was big.
This thing here is the neck vertebra of a medium-sized rhinoceros from the Ice Age. And it's, well, it's a large bone, but it's nothing compared to this, which is huge.
They had found an ancient type of rhino called an Indracothea.
When we think of large land animals, we always think of dinosaurs. And dinosaurs were the largest land animals that we know about. But some of the land mammals also got very large, such as this Indracothea here, which stands 7 to 8 meters tall, is about as long, and would have weighed perhaps up to 15 tons. And as you can see, I don't even reach up to the top of its legs.
The Indracotheas were rhinos trying to be giraffes. They had long necks to reach the treetops, but everything about them was massive and heavy like a rhino. They were an extraordinary feat of engineering. But these monsters were gentle giants, browsing only on tender young leaves. In the case of the Indracotheas, that was a lot of leaves.
Why be big? Well, of course, it means that you have nothing that's going to hunt you. There is no predator that's big enough to eat you. But the danger of being big is, of course, you can be quite vulnerable, because population sizes, if you think of elephants, are quite small, and it doesn't take much to drive a large animal to extinction.
And the days of the Indracotheas were numbered as the Earth changed again. Antarctica's increasing isolation brought a shiver to the climate. As ice spread at the South Pole, it shifted the weather patterns, bringing new seasonal extremes of drought and deluge. Out of the turmoil, an astonishing new plant evolved, one that we couldn't imagine life without. It was grass.
People often think that grass has always been on the Earth. It's so common, it's everywhere. You even see pictures of dinosaurs wandering about on grassy fields, but that's not possible. The first grasses appeared in the fossil record about 30 or 40 million years ago. And when they appeared, they did take over. There was a change in climates which got drier. The centers of continents became great savannas. And as the savannas grew, the grasslands expanded, the woodlands that had been the early home of the mammals disappeared or to the fringes. The mammals had to adapt. They came down from the trees, out from under the trees. They became bigger, longer legs, hooves, able to run faster, and their teeth had to adapt.
Many of the animals that browsed on leaves went into decline. In their place came a new breed of mammals, the grazers. But grass is surprisingly difficult to survive on. Luckily, mammals had the answer. They developed a battery of teeth, complex stomachs, and long legs to follow the grass wherever it sprouted. But where there was meat on the hoof, predators were quick to follow. The competition for survival brought with it some of the most deadly animals on Earth.
If we look at the evolution of cats, indeed the evolution of other predators, we can see that they've got faster, they've got bigger, they've got better at what they do. Equally, the prey species have got faster, bigger, better at what they do, which is to escape. There's what you might call an evolutionary arms race between the two. The prey want to get away, the predators want to catch them. And so over time, there has been a tendency to do the best they can to reach the optimum solution.
The cat family are the ultimate predators. No other mammal is such a finely tuned assassin.
What makes a cat such an efficient killing mechanism? Well, these tiger cubs are 4 months old, and already they've got all the attributes that they'll need, just in a smaller form. They've got large feet, very large paws, long claws, very sharp. They've got teeth that are able to slice off meat, able to bite into the prey, able to kill it. They've got whiskers to sense exactly where the item is so that it can bite precisely. They're strong, well-muscled, and they're fast-moving. So the whole package combines together to make an animal that really is superbly equipped for what it needs to do.
A full-grown Siberian tiger can weigh as much as 300 kilograms and is the largest cat today. But compared to some of its ancestors, it would look like a pussycat. There was a creature that died out just a few thousand years ago with the most lethal weapons of any carnivore. It was called Smilodon, the fabled saber-toothed cat with its 20-centimeter long teeth. Although the sabers were Smilodon's most dramatic feature, it's the whole package that made it such a lethal killing machine.
If you look at the skeleton as a whole, it was a very, very strongly built cat. The forequarters in particular, the front legs, the shoulders, the neck, are extremely heavily built. Like many cats living today, it was probably fast over a short distance. It was probably an ambush predator able to sprint out from cover, using its speed in order to close the distance very quickly, and then using its great strength to seize the prey and pull it down.
Thanks, Alex. I think I should use it in the end.
As usual, it's the teeth that really tell you how Smilodon went about its business.
If you look at the skull of a Smilodon, your eye is immediately drawn to these saber teeth. But it's got teeth at the back here that are equipped for slicing meat. It's got teeth at the front that are equipped for pulling meat off, getting it into the mouth. It's got large upper canine teeth that are equipped for slicing into the prey once it's held immobilized. So everything about it shouts predator at us. This is not an animal that can eat grass or vegetation. It's a predator, it's a killer.
The giant sabers were there for one gruesome purpose: to be driven into the neck of the prey and in one bite to rip its throat out. Although the mammals seemed to be on top of the world, conquering every habitat, the Earth was about to create the biggest challenge yet: life in the freezer. Both of the Earth's poles began to freeze over 2.5 million years ago. The Ice Age had begun. Ice sheets grew beyond the Arctic Circle over much of the Northern Hemisphere, transforming all plant and animal life. At the height of the Ice Age, there were icebergs off the coast of Ireland, permafrost beneath London, and glaciers reached as far south as New York. For most animals, it became an inhospitable place,